In the following presentation, we will be reviewing the Exact Slide cable-operated system and how to successfully troubleshoot customer concerns. During the design process, each system is developed for a unique floor plan with specific wall opening heights, lengths, and room dimensions, along with the weight to determine the appropriate system for the application. Once the design is complete, a prototype is produced. Our sales team, along with our technicians, go on site to the OEM to install the prototype to ensure that it works for the application. The Exact Slide contains a concealed motor at the top of each column, or jam assembly, that is installed in the rough opening of the main wall and has a controller that sends a signal to the motors when the switch is operated, whereas the AccuSlide has a single motor at the top or bottom of the main wall opening that receives a signal directly from the switch. Let's watch an overview of the Exact Slide.
This is our Exact Slide mechanism, often referred to as the G5.5. The way this system is set up is that we have a motor located at the top of each column, and on the other side of this gearbox housing there's a gear that rotates. On the gear we have a chain that's draped over the top of that, and on each side of the chain we have two cables that are hooked up to it. So as the gear is turning, it wants to pull one side of the chain up and force the other side of the chain down, causing it to pull on two cables at a time, which in turn controls the direction of movement. Each side of the system runs independently of each other, and what joins them together is our Exact Slide room controller. So you can see as I give power to the slide room, we have a green light that comes on right here. That green light just shows that power is being sent through the controller. It'll turn off after 5 minutes and it'll go to sleep. Anytime that you have a red and a green light flashing, that is an indicator of low voltage. If you're under a low voltage scenario, it'll play with the synchronization of the slide room, making it come out of whack, but you can manually override it with our electronic override buttons, which are these red buttons located at the bottom corner of the controller itself. If the controller is wired correctly, you can press on one of these red buttons at a time and it'll give all power to each motor, allowing you to dog track the room all the way in. Okay. If for whatever reason you're out of sync and you need to reset the controller, you can press down on both of these red buttons at the same time. Hold them for about 4 seconds and you'll see a red LED light flash like that. At that point, it's wiped whatever memory it's learned up to that point, and you'll want to cycle the room 3 full cycles for it to recalibrate the weight of the room for the controller.
Now we will review the cable-to-chain relationship. As you can see, each motor has one chain that connects to all 4 cables on each side. The exterior bottom cable pulls on the top interior cable when the room is extended. When the room is retracted, the interior top cable pulls on the bottom exterior cable. The exterior top cable would then pull on the interior bottom cable when the room is extended. When the room is retracted, the interior bottom cable pulls on the exterior top cable. It is important to know what surface the room is gliding on when working with any cable-operated system. Wear bars, rollers, and flush floor pans are 3 of the main types. A flush floor is best described as a room that travels at an angle when the room is extended, so that when it is fully extended, the floor of the slide box and the main floor of the RV sit level with each other. The BAL flush floor system is a combination of a drop-in pan which sits lower than the main floor of the RV. It includes a wear bar with a compression roller at each end of the pan. Inside the compression roller is a rubber compression block. There are various sizes of the compression blocks based on the size and the weight of the rooms. In this section, we will cover real-world examples experienced by our technical support team. BAL cables are pull tested at 2,000 pounds. As they are aircraft cables, in order for them to fray, another variable or component has typically inflicted damage to the cable itself. The location of the interior and exterior standoff brackets is important. To check the location of the exterior standoff brackets, extend the room 6 inches and check to ensure that the cable is level or within 1/8 inch of level. If not, as the room retracts, it will create a pinch point at the ball end or bullet end of the cable. These brackets are adjustable without disconnecting the cables. Twisted cables or unspun cables are caused by adjusting tension without the use of needle nose pliers. Clamping the needle nose pliers to the barrel of the threaded cable end before adjusting the tension will prevent this issue. The Exact Slide has 2 cable replacement kits. As the exterior and interior cables use different cable ends where they attach to the standoff brackets. These part numbers are also listed on the BAL RV Products website. The cable patch kit is also listed, as most individuals prefer changing these at the same time of a cable replacement. Now we will review the process for changing the top exterior cable and a bottom interior cable.
On the Exact Slide, your first major indicator of needing a readjustment would be whenever the room's fully extended and the exterior top cable is sagging like so. When the cable is sagging, that tells me that there's slack in the chain. And anytime you have slack in the chain, you can experience popping sounds or skipping teeth that the chain's wanting to skip on the gear. With the Exact Slide, the only way you can adjust it is with the room completely retracted. By fully retracting the room, it forces all the slack from the exterior cables and the exterior portion of the chain to where we can adjust the tension of everything with just the interior cables. It's important to make sure the room is fully retracted, or else you won't be able to capture all of the slack. The first step in the adjustment is removing the jam nuts from the ends of the cables. Once the jam nuts are removed, we're going to first loosen the interior top cable as if it's barely hooked up. What that does is that it relieves the slack in the chain to where we can tension the chain with the interior bottom cables. Take note that when you're tightening this interior bottom cable, not only are you tightening the cable, but you're going to be tightening the chain and your exterior top cable at the same time. We're going to clamp on the cable on the back side here. This is an example that with the fascia on, you can still make this adjustment. We're going to tighten this adjustment nut. We're going to tighten this adjustment nut until we tension the cable to where we have a 1/4 inch deflection, meaning we should be able to grab this cable with our thumb and pointer finger and be able to easily lift it up a 1/4 inch, easily push it down a 1/4 inch from center. Okay. Once the bottom cable's tensioned, we're going to go to the interior top cable, and we're going to tension this interior top cable until we reach a 1/2 inch deflection. We want the interior top cable to be twice as loose as our interior bottom cable to ensure that it's not going to pull any slack in the chain upward towards the motor. Then we're going to repeat the same thing on the other side. With the interior cables tensioned properly, we can double check our adjustment by running the room all the way out. The first thing we want to check is to see if we are sealing properly in the fully extended position. What we consider a seal is when these black standoff brackets are making contact with our aluminum columns, both on our top and on our bottom standoff brackets on both sides. The second thing we're going to check is exterior cable tension. The way we're going to do that is with these two fingers, we're going to grab the bottom cable. We should have a 1/4 of an inch deflection, meaning we should be able to easily lift it up a 1/4 of an inch, push it down a 1/4 of an inch from center. If the bottom cable is slightly tighter than that, it's perfectly normal because the bottom cables are what carry the load on this system. The exterior top, however, is going to be a 1/2 inch deflection. 1/2 inch up, 1/2 inch down from center. When the room is fully extended, your exterior top cables are always going to be looser than your exterior bottom cables. The tension that we're feeling for is a 1/4 of an inch deflection for the bottom or slightly tighter, and a 1/2 inch deflection for the top. The last thing we're going to check is to see if the room is sealed completely in the retracted position. The T-metal should compress the bulb seal 50% or more from bottom to top. With our adjustments confirmed, we can lock all our adjustments in place with these jam nuts on each cable. If I'm able to loosen it by hand, it's not tight enough.
The number one misdiagnosed customer complaint is popping and grinding sounds coming from the system. This sound is caused by having slack in the chain or cables, whereas the loose chain will slip over the teeth on the sprocket of the motor and gearbox assembly, which causes a loud pop. To remove the slack in the chain, the room has to be completely retracted to the end position. Loosen the top interior cable on that side, which will keep the tension from working against you. By tightening the bottom interior cable to a 1/4 inch deflection and then moving back to the top interior cable and tightening it to a 1/2 inch deflection, the slack will be removed. It is important to have the room completely retracted during the tensioning process, for all of the slack in the cables and chains will move to the correct side before tensioning. The slack in the cables and chain is closer to the exterior wall when the room is retracted. The slack then moves closer to the interior when the room is extended. The slack is trapped when the room is extended and cannot be tensioned out. When experiencing out-of-sync issues on the right and left-hand side of the slide room, the first check should be to determine if the room seals when it is in the retracted or in the extended position. If the room seals in both positions, it is okay to have a 2-inch variance from left to right in lag time. Again, as long as the lagging side catches up at the end of the cycle and the room seals. In the event the issue is more prominent than a 2-inch of lag, check the controller label to determine if it has a white label or a blue label. The blue label controller has additional programming for keeping the right and left motor in time with each other, as well as improved low voltage protection. Low voltage protection in the blue label controller is set at 9 volts. In the event the power supply drops to 9 volts under load while the room is being operated, the controller will cease working to protect the board from overheating and damaging the control board. Green and red light indicators also alert you in the event there is a wiring issue. Resistance between the opening and the main wall and the room can trick the controller into thinking one side is sealed, which will redirect power away from that side. After confirming the cables are tensioned properly and verifying that the voltage is 10 volts or higher at each motor, check for obstructions and resistance. Applying an alternate power source directly to the controller to operate the room will indicate if the issue is further upstream in the electrical system. If the room operates correctly with an alternate power source, then we know that the controller and the motors are all okay and the resistance is not the issue. Determining what surface the room is riding on is key to addressing a resistance-related issue. For designs that utilize a wear bar, you will want to verify that the wear bar is secured across the length of the opening and that no screw heads are lifting higher than the wear bar itself. This would be evident by hard lines cutting into the bottom of the room's exterior surface. Ensure that rollers, when equipped, still spin and are not seized or jammed with debris. Validate that flush floor applications using a compression roller have a rubber compression block that is rebounding as the room is retracted. Once the cable tensioning is validated and all other obstructions are ruled out, check the exterior perimeter of the room by pulling back the wipe seal and running your fingers up and down the gap. You are looking for what we refer to as an even reveal. An even reveal essentially means that the gap on each side is the same width from top to bottom on that particular side. If a corner is tighter in one area, go to the interior of the RV and remove the jam clamp on that side to validate that the jam is fully seated into the opening and is secured and not twisted. The function of the jam clamp is to brace the jam assembly from the interior of the coach. When the jam clamp is fully seated into the channel from top to bottom of the jam assembly and fastened into place, it will not allow the jam to twist during operation. Operating the room with the jam clamp off or not fully seated in the channel from top to bottom will cause the base bracket of the jam assembly to twist and can cause damage. Water infiltration can be prevented or corrected by validating and applying seal in the following areas. The top bulb seal is recommended to have a bead of silicone along the top edge. The main wall opening or rough opening should have a water dam created at each end of the sill material that is used. Verify that the T-mold is not flaring, which will interfere with the bulb seal compression when the room is retracted for travel or storage. Models equipped with a wear bar should have seal at each end of the wear bar where it meets the bottom inside edge of the jam. The bottom sill material should be supported along the interior back edge to prevent that edge from tilting inward toward the interior of the RV. The inside top edge and the exterior top face of the jam should also be sealed. Interior standoff brackets will not pull or rip out of the end walls of the slide out unless they have been installed with self-tapping screws, as the end walls are lumber or lumber core aluminum tubes. Self-tapping screws would bore holes through the lumber and eventually pull out of the wall. Self-tappers can be used on the exterior standoff brackets because they are attached directly to the metal leg of the T-mold. In the event this does occur, the part number 217-00148 can be ordered through the RV OEM or your local RV parts distributor for the reinforcement plates for the interior standoff bracket. If you experience an issue where one motor works and one does not, you can switch the connections for the M1 positive and M2 positive at the controller to see if the non-working motor will now operate. If it does, you have confirmed that the motors are not the problem and the controller needs to be replaced. Low voltage protection in the blue label controller is set at 9 volts. In the event the power supply drops to 9 volts under load while the room is being operated, the controller will cease working to protect the board from overheating and damaging the control board. Green and red light indicators also alert you in the event there is a wiring issue. Resistance between the opening in the main wall and the room can trick the controller into thinking one side is sealed, which will redirect power away from that side. After confirming the cables are tensioned properly and verifying that the voltage is 10 volts or higher at each motor, check for obstructions and resistance.